Welcome to this HP Video Technical Configuration Guide. In this video, we're discussing the configuration of PVST or per VLAN spanning tree and rapid PVST Plus on HP ProVision and Cisco switches. This is the second part of this TCG. In the previous part, we looked at an overview, guidelines, command explanations, and show commands with regards to the interoperability of HP ProVision and Cisco switches running PVST or rapid PVST. In this part, we're going to continue the discussion with a practical demonstration with the setup and testing of HP ProVision and Cisco switches running rapid PVST. So now let's configure the topology. ProVision 1 is going to be the root for VLANs 1, 3, and 5. Cisco 1 is going to be the root for VLANs 2 and 4. We're going to be running rapid PVST Plus in this topology. So on ProVision 1, we're going to enable rapid spanning tree. Set the priority for VLANs 1, 3, and 5 to 0. Priority for VLANs 2 and 4 to 1, which equates to 4096. We'll enable spanning tree. On ProVision 2, we'll simply set the mode to rapid PVST and enable spanning tree. On Cisco 1, we'll set the mode to rapid spanning tree. The priorities will be an inverse of ProVision 1. So Cisco 1 will be the root for VLANs 2 and 4 and the backup root for VLANs 1, 3, and 5. On Cisco 2, we'll simply enable rapid PVST, and on both the switches we'll set the path cost to long. In other words, the switches will use the industry standard cost values. So on ProVision 1, show spanning tree. Spanning tree is not enabled on ProVision 1. What about ProVision 2? Show spanning tree. Spanning tree is also not enabled on ProVision 2. What about the Cisco switches? Cisco 1. Show spanning tree. Now it says IEEE, but if we look at the summary, notice the mode is PVST. Cisco 2 shows spanning tree. Protocol enabled is IEEE, but if we look at the summary, notice the mode is PVST. So PVST is enabled by default on Cisco 1 and Cisco 2. Spanning tree is disabled on ProVision 1 and ProVision 2, which is once again the default on ProVision switches. So pasting the configuration on Cisco 1. Show spanning tree. Summary. The mode has changed to rapid PVST. On Cisco 2. Show spanning tree summary. The mode has changed to rapid PVST. So both Cisco 1 and Cisco 2 are running rapid PVST. Show spanning tree shows that port 1 and 2 are forwarding on Cisco 1 and port 10 is blocking for VLAN 1. Show spanning tree on Cisco 2. Notice port 1 is forwarding, port 2 is blocking. There's a loop in this topology, and ProVision 1 and ProVision 2 haven't got spanning tree enabled. So for example, from Cisco 1's point of view, there's a loop on interface F102 and F1010. On ProVision 1, paste the configuration, but I'm not going to enable spanning tree at this point. ProVision 2, paste the configuration. But once again, I'm not going to enable spanning tree at this point. Now that I've got the command spanning tree ready on both switches, I'm going to enable spanning tree on both ProVision 1 and ProVision 2. So, show spanning tree. Notice spanning tree is enabled and the mode used is rapid PVST. Provision 2, show spanning tree. Spanning tree is also enabled on this device, and the mode is rapid PVST. Back on Cisco 1, show spanning tree. Notice the root port on Cisco 1 is F1010, indicating that Provision 1 is the root. Let's check that. So, show spanning tree root. The local switch is the root for VLAN 2. Notice the root cost is 0. The same is true for VLAN 4. We can check that once again by typing show spanning tree, scrolling down to VLAN 2, and notice the output here tells us that this switch or bridge is the root for VLAN 2. There's a cost of 200,000 to get to the root on VLAN 3, but notice the local switch is the root for VLAN 4. So, there's a cost of 200,000 to get to the root switch on VLAN 1, 3, and 5 using port F1010. On Provision 1, show spanning tree. Notice the switch MAC address ending in C700 is the root for VLAN 1, VLAN 3, and VLAN 5. So Provision 1 has correctly become the root for odd VLANs, and Cisco 1 is the root for even VLANs. Let's look at the load sharing on Cisco 2 and Provision 2. On Cisco 2, show spanning tree. On VLAN 1, the root port is F102, which is the link going to Provision 1. That's correct. The blocking port is F101. For VLAN 4, notice F101 is the root port and F102 is the blocking port or alternate port, which is correct. For VLAN 5, F102 is the root port, F101 is the blocking or alternate port. So load sharing is taking place on Cisco 2. So that's correct. Let's look at Provision 2. So on Provision 2, show spanning tree VLAN 1. The root port for VLAN 1 is port 7, which is correct, with a cost of 20,000. Port 8 is showing as designated port. Going back to Cisco 1, show spanning tree on Cisco 1 shows us that port 102 is blocking. It's the alternate port. Now the reason for that is that on this link, the path via Provision 2 is seen as a better path to get to Provision 1 than the path via Cisco 1. The reason for that is this link is running at 100 megabits per second because of the fast Ethernet port on Cisco 1. This link is also running at 100 megabits per second because of the fast Ethernet interface on Cisco 1. But these interfaces are gigabit interfaces, so this interface is running at 1 gigabits per second. So port 8 on Provision 2 has been chosen as the designated port rather than F102. Now to optimize spanning tree, what you need to do is to increase the cost of this interface so that the blocking port or discarding port is on Provision 2 rather than on the core switch. Back on Provision 2, what does it look like for VLAN 2? For VLAN 2, port 8 is the root port and port 7 is the alternate port. That's correct for VLAN 2. What about VLAN 3? For VLAN 3, port 7 is the root port and port 8 is the designated port. So the topology will work because traffic for VLAN 2 is sent out of port 8 and traffic for VLAN 1 and 3 is sent out of port 7. But to optimize spanning tree, we want to have the discarding port here and the designated port on Cisco 1. So to do that, we'll change the cost of port 7 on ProVision 2. So on ProVision 2, conf t, spanning tree, or rather spanning tree, port 7, VLAN, and in this case we're going to specify VLAN 1, path cost, and we'll change it to 200,000. Show spanning tree, VLAN 1. Notice the root port is port 7 and the alternate port is port 8. Going back to Cisco 1, show spanning tree. Port 2 is now the designated port, so spanning tree has been optimized for VLAN 1. Let's do something similar for VLAN 3. So for VLAN 3, spanning tree, port 7, VLAN 3, path cost, 200,000. Show spanning tree VLAN 3. Notice now port 7 is the root port, port 8 is the alternate port, which is correct. On Cisco 1, show spanning tree VLAN 3. Fast Ethernet 102 is now the designated port. Port 10 is still the root port. So we've optimized spanning tree on ProVision 3. Notice for VLAN 2, the root port is port 8, but for VLAN 3, the root port is port 7. That concludes this video demonstrating and explaining the configuration of per VLAN spanning tree, in this case rapid PVST, on ProVision switches and Cisco switches. I explained the commands and demonstrated how to load share different VLANs across multiple uplinks by changing the priorities for VLANs on ProVision and Cisco switches.